Hi, I'm Darren and welcome to Level Up Double E Lab and the second part in my series on restoring this Drake TR-3. And as you can see since the first episode, it's shed a few parts, which is a good thing because that means I'm into the repairs and restorations. Let's check it out. Let's pop the cover off this bad boy and have a look inside. Here's the chassis in all its vacuum tube and copper glory. There's 20 vacuum tubes in this design and they're all present. Even the 5 tube shields are right where they're supposed to be. Here in the back left corner we find the 3 12JB6s that make up the RF final power amplifier. The 12JB6 along with its 6-volt counterpart the 6JB6 are beam power tubes. Apparently they were used in televisions as horizontal deflection amplifiers, but many radio manufacturers, including Drake, use them in their RF power amps. Of course, there's the mandatory coating of dust that's accumulated on everything. None of the topside components are showing any alarming signs of overheating or physical damage though. All 5 of the overtone crystals are present, that's good. One item though that isn't factory original is the transmit-receive relay. Also, it looks like the incandescent protection lamp for the receive circuit has been reconfigured. But the highlight on these old Drake rigs has to be the metal chassis itself. It's made from copper-plated steel. That's a very noticeable feature on Drake's gear from this era. And unfortunately, the finish on this one is not in very good shape. Okay, time to check out the underside of the chassis. Wow, the underside looks a lot cleaner than the topside. Just look at the shine on that copper. Those added blue wires coming from that terminal strip are the only obvious evidence of any modifications. Clearly this rig has never been hacked up. It even looks like it still has all of the original film capacitors too. Man, I can't imagine the skill level and workmanship and man hours involved to build one of these. There's gotta be close to 1,000 solder joints in here, and every one of them done by hand. Even the wiring looks like it was built up on the chassis a conductor at a time because there's no lacing on the wiring loom. Instead, every inch or so there's a scrap bit of wire that's used like a wire tie to squeeze the bundle together. So after doing this survey of the chassis, I'm very optimistic that I should be able to get this guy back on the air. Another reason for my optimism is that this is not my first TR-3 rodeo. I bought this TR-3 off of eBay 3 years ago and restored it to full working condition, and its starting condition was considerably worse. The most serious problem that I had to deal with was the condition of the chassis. The top surface was badly corroded. It had red rust in many areas, even some pitting where the steel was being eaten away. I had no choice but to remove everything from the top surface of the chassis, remove every protruding screw from underneath, sand it down to remove the rust, prime it, and paint it. I think it turned out great, and it saved what otherwise was going to become a parts-only rig or worse, another piece of our amateur radio history sent to the scrapyard. A bright and shiny copper chassis is something that Drake is well known for, so why did they do it? Well, one explanation that's been around for a while is that the copper improved the electrical conductivity and the RF properties of the chassis. But I'd be surprised if there's any data that really substantiates that, mostly because if you look at the competition of that era, copper plating chassis was not common, and even Drake themselves stopped doing it in later years. Still, another claim is that the copper provides corrosion protection for the steel, but even that claim is shaky at best because the copper certainly does not provide galvanic protection. If you look at the galvanic chart, copper is more noble than steel, which means in a corrosive environment, the steel is going to oxidize before the copper does. At best, the copper can act as a barrier coating, and like all types of barrier coatings, which include things like tin plating and nickel plating and all types of paints, any imperfections in the barrier coating will expose the substrate, and those can be initiation points for corrosion and oxidation to start. And that's exactly what happens historically on these Drakes. You see all those little areas that eventually turn into blisters that spread and eventually red rust. In my opinion, based on 0 hours of research and not having talked to anybody who used to work for RL Drake, I think it's just bling. Like any manufacturer, they needed something to make their product stand out and distinguish it amongst all the other competitors of that time, and a copper-plated chassis poking through the ventilation holes on the cover would certainly do that. Plus, it gives the owner some incentive to keep it clean and looking sharp. First step in the sequence of disassembly is, of course, to pull all of the tubes. These egg cartons make great organizers and keep the tubes from rolling around and getting damaged. I'll run them through my tube tester shortly. Next is to remove the knobs in the front panel. A few of the knobs are held on with grub screws like the main tuning knob. The rest just pull off. And once they're removed, the front panel needs to come off too. There's only 4 screws and 4 spacers holding it in place. I remove it for cleaning and to keep it away from the rest of the work so it doesn't get damaged. I'll also pull the 2 meters out so I can test them and clean their mounting brackets. I also remove a few other fragile items like these crystals. And finally, I pull out the PTO. The illumination shield needs to come off before the PTO can be removed, and this gives us a chance to see another one of Drake's signature items, this blue light filter for the dial illumination. The meters also have a sheet of this film, and it creates a really cool blue glow in the dark. After I unsolder the 3 electrical connections, next step is removing the 3 nuts holding the PTO to the chassis. Now, removing the PTO is not absolutely necessary to clean it, but this particular one has a lot of excessive lube on it and accumulation of debris. Cleaning it will be much easier and less risky by pulling it out first. I finished cleaning the PTO and I've got it about halfway put back together. I thought I'd take a quick shot here of the progress and talk about what I found. Now, one thing that was evident when I took this off the TR-3 is just how dirty and filthy it was. There was so much extra grease and oil that had been applied to this over the years, and of course that's just going to attract and retain lint and dust and all kinds of debris. So I got all that cleaned off, and really the only 2 areas that really need to be lubricated here, there's ball bearings right here, and I put a little bit of Krytox lube in there, so those are fine now. And then just a single drop of machine oil on the fine pitch screw here, so as that runs back and forth and pulls the slug in and out. And I'll try to turn this around here. I don't know how this is going to focus, but you can see the slug right here. That's why this is called a PTO. It's a permeability tuned oscillator. So this is, like I say, about halfway put back together. I do have to put the rest of the gear train, the dial back on. I got a couple issues to deal with. One is I lost the indexing for what the hard stop is on the PTO, meaning where the slug should be when this wheel turns around and this little locking pin kind of drops into that slot right there. So I'm going to have to look at my other TR-3 and kind of reverse engineer how to do that. And the second thing is I have to deal with, there's a little wave washer right here that provided some compression force on the dial, and as I was taking it apart, it was fractured. It didn't break when I took it apart. It was broken underneath the little lock ring that's there. So I don't have an exact replacement, but I've got something that's close enough. It's the right ID. It's not the same OD, but it's definitely a wave washer. And really all it needs to do is provide a little bit of compression on here, and it's just friction so that this doesn't spin easily relative to that. So I'll put this all back together, including this new wave washer, and then get it back in the unit. I made some really good progress here on the TR-3, and I thought I'd go through what I've accomplished so far, starting with the stuff that we can see on the top side. So first and foremost, I've finished cleaning the chassis. At least I've gone as far as I would consider safe to go. And unfortunately, as you can see, there's quite a bit of corrosion on here still. It's just the sad reality of these old copper chassis that the copper is just not going to last very long unless it's well maintained, and this one just wasn't well maintained. All the little speckles that you see on there are essentially where a speck of dust or something accumulated over the years, and it attracted moisture and it eventually broke down. But I think it's the lacquer on top of the copper, then the copper broke down and now it's getting into the steel. And it's especially concerning over here on the left side where there's really not that much copper left. And really the only other thing to do at this point would be to strip the chassis down far enough where you can paint it like I did on my other TR-3, or even more radically, strip it completely down and then take the bare chassis out to a shop that can strip it back to the steel and replate it. Just not worth it, and this is a case where I'm just going to try not to do any more harm. So I got the dust, the grease, and the grime off of it, and that's as far as I can safely go. Next, I did finish cleaning and reassembling the PTO and got it reinstalled, and it's working mechanically great right now. Feels really nice, and it's definitely much cleaner in this area than it was before. Now, you may notice a little addition here. There's a little piece of solder braid. This is a ground strap from the little yoke that carries the slug, connecting it to the body of the PTO. And I've read in the forums that that's a recommended practice to do, just to take any static electricity, I'm trying to say, that might build up on this and alter the behavior of the PTO, and just make sure that those are bonded together. So an easy thing to do, and I did that. Next up, I checked all of the pots using my IM13, my good old Heathkit vacuum tube voltmeter. And there were 8 of them if you count all of the double ones, a dual one here, a dual one down here. So I prefer using the analog meter, the vacuum tube voltmeter, to test those, because if you have a pot that's intermittent, you'll see it immediately when that needle starts to behave erratically. So definitely prefer doing that. And of course, a good pot is going to look nice and smooth, but a bad one's going to look glitchy. And all of them check out fine, except the one that I really didn't want to have to deal with. It's this guy back here. It's the carrier balance, carrier adjust pot. And that is notoriously weak on these Drake rigs, the TR-3 and the TR-4, maybe other ones that used it. It's an unobtainium part. You just cannot find it new anywhere, because it was a special multi-turn pot. It's 200 ohms, so it's a bit of an oddball value. But I've got an idea of how to replace that. Now, on my other TR-3, I temporarily cobbled in a conventional pot just to get the rig working. But what I think I'm going to do is just use a regular circuit board mounted trimmer and find a way to put that in there and have it look a whole lot better. So I'll have to come up with that as part of my restoration here. And if that pot were flaky and intermittent, that might explain why my dad was having trouble with this transmitting, because that's part of the balance modulator circuit, I think. And if that was flaky, you might not be able to transmit. But there's another clue for why this rig may not have been transmitting, and we'll see that when I flip the chassis over and we look at the other side. Let's talk about the tubes for a minute. There are 20 of them in this bad boy, and I checked them all on my Sencor tube tester. And as I always say, a tube tester won't tell you if a tube is 100% good, but it will catch some of the most common things to be concerned about, and certainly will catch ones that are just outright dead. 17 of the 20 tested fine. Of the 3 remaining, one of which is the OA2. That's a 150 volt regulator. My Sencor just can't test that, but those generally are okay, and if it's not, they're easy to find, and I actually have a couple spares. The other tube, tube V5, that's a 12BA6, it failed for leakage and shorts, but on this rig it's used for the 100 kilohertz crystal calibrator, so it might be fine in that circuit. It just doesn't see much use. And there are 4 other 12BA6 in the rig, and they all tested fine. And I have, I don't know, 3 or 4 spare 12BA6s, so if I have to replace it, no big deal. And you can even buy them fairly easily today still. And the last one, V16, it's a 6GX6, and this little guy, unfortunately, failed also for grid leakage, and it does a lot of things here. On receive, it's both the beat frequency oscillator and the product detector. It's got 2 separate tube circuits, and it relates 2 tubes in one. And on transmit, it does the 9 megahertz oscillator duty. So it's kind of important. And like I said, it failed for grid leakage, but I'm going to try it anyway. If it doesn't work correctly, I'll replace it later if I have to. Next item is I did remove the 2 meters temporarily so I could clean off the gunk that was around the structure that holds them in place. But I also do something here that I think is very important on these old rigs. I check the meter to make sure, check the meters in this case, to make sure they're actually working correctly for their full scale values and that they don't have any glitches. So these are 5 milliamp full scale meters, and it's pretty easy to test them out. Just hooked them up in series with a I think it was a 1K resistor, and with a variable voltage coming out of my Heathkit power supply, just verified that they moved up and down smoothly and that they did reach full scale or pretty close to it at 5 milliamps, and they work just fine. And like I say, I do that to make sure they're working because, among other things, I'm going to rely on those meters when I do the alignment, and I need to have faith in them that they're reading correctly. Next item is I did trace these 2 blue wires. There's a third one down here. This is this add-on terminal strip that was on the back, if you remember. And essentially, these aren't doing a darn thing. I am not really sure at all what they were put in for. They actually poke up over here in the vicinity of I think it's the transmit gain control, and they're not connected. So I'm going to remove them. They're serving no purpose, so out they come. Let's talk about the transmit receive relay. It goes into this socket right here, and this socket is soldered to this circuit board here, and this circuit board is soldered to a bunch of feed-through capacitors. Now, this is not Drake factory original. This is actually a modification that was done later to this rig, and I think I know pretty accurately when this was done, because as part of the paperwork that my dad got with this rig when he bought it, there were 2 clues here. One is just some notes to say that there was a relay mod kit costing about $20 that was ordered in presumably 1985. And then to kind of support that in the paperwork was a packing slip that described the relay mod kit, and it's also dated 1985, August 14th, 1985. So that kind of makes sense that this rig was modified using a Drake kit, because these were a notoriously weak area on these rigs. Those factory relays tended to go bad, and they were not in a socket at the time, so the kit put them in a socket. And here's the relay that came with this guy as I got it, and it tests good. I pulled it out, checked it on a power supply, and the coil energizes and the contacts move, and it goes clickety-clack. So it's as far as I got with it, but it seems to still work. But if it is bad, I looked up the part number that's on there, and that part number is still available new today. This is about a $30 relay, so it's not cheap, but the good news is it's available. The not so good news is looking right here. You can see this red wire kind of dangling loose here. Apparently what's happened is the trace on this board from this feed-through capacitor to this terminal of the relay had gone open, and somebody had just soldered that little jumper in there and then jammed the end of the wire into the terminal socket there, and then the blade of the relay kind of wedged it in there. So I'm not going to leave that. So unfortunately I'm going to have to desolder and remove this board, and more than likely I'm going to confirm that there's a bad trace on here. So it leaves you with a couple of options. I'm certainly optimistic that I could reverse engineer this board and fab my own to replace it if I want to spend that much time to do it. The shortcut is this kit is still available today. I'm not sure if it's the original Drake one or not, but there is a kit out there that has the circuit board, the socket, the relay. Unfortunately, it's about $60 or so, so that's a pretty painful expense to have to pay to get that area working again. So we'll see when I pull that board out what I have to do next. All right, I flipped the rig over so we can take a look at the underside of the chassis, and one of the first things to talk about are all the resistors that are in here. And I did a survey and checked each one with a multimeter, and I found only about 10 or so that are more than 10% out of spec, and that's pretty good. On my other TR-3, I had found, I think it was closer to 30 of them that were out of spec, and quite a few of them were more than 10% out. So a lot of work on that rig to replace the bad resistors. And speaking of the work, it's really difficult to get in on these small vertical boards and remove and desolder and solder in a replacement component. So what I did on the other TR-3 is I removed these boards, and it may seem like a lot of work. Kind of is, because there's a lot of connections on these boards, but it's just so much easier to get them out and get them into a work vise and have a lot more space to work on them. You can do a much better job. And plus, I've got to replace several caps in here too. These film caps have got to be replaced as well. It's just so much easier to take the boards out and do that. And I saved my notes from the last time I did that project, and in my notes I have a map that I made from looking at the underside of the chassis of all the locations. I can hit the map upside down, turn around this way so it aligns with I've got the rig. So I've got each of those boards. I just arbitrarily gave them a designation, and then I also made little diagrams of each board that shows which resistor is on there, which value and numbering notation it is from the schematic, along with the other external connections like the wires that are on the edges of the boards and where they routed to. So this is going to really help me as I go through this, and it's kind of meticulous, but definitely made a big difference when I worked on that other TR-3, and I'll use it again here when I replace those components. And speaking of the resistors, I found a significant clue for why the rig might not have been working correctly, as I hinted when I was doing the survey of the top part of the chassis. Let's zoom in here. This is resistor R40. It's a 470 ohm resistor, and it's split. Ain't no electrons going from side A to side B through that guy anymore. And it's in the circuit. It feeds plus 250 volts DC to transformer T10. Now, I haven't studied the circuit enough at this point to know if disabling T10 is enough to prevent the rig from transmitting, but certainly it ain't going to work right if there's no plus 250 volts going into that coupling transformer. So definitely going to replace that guy. And for my eagle-eyed viewers, I think you can just barely see a glimpse of R40 in the, I guess, the high-level survey shot that I showed at the beginning of this episode. You can kind of zoom in, or pause it, I should say, right there, and you can see there's R40. He's broken. Next item was that third blue wire that was on that added terminal strip, and it actually routes, as I said a moment ago, to a circuit that's on the underside of the chassis, and I'll zoom in and we can see it here in a minute. But I thought we'd look in the manual because apparently the person who did it was kind enough to draw a neat little schematic of what it is, and I have no idea what it does. There's a 1N479 diode in parallel with a pretty high value resistor, 1.1 meg, then connected to it, 0.001 mic cap apparently in parallel with a 2N3646 silicon NPN transistor connected kind of reverse bias to ground. And I am vaguely remembering there was a purpose for doing that with a transistor, but without having to go do my homework, I don't remember what it was. And if any of you guys know, please say so in the comments below, and even better if you know what this circuit might be doing, because this wire here that kind of runs over to this side of the relay connects to the circuit that's called the receive cathode in the rig, and that circuit goes to a lot of the cathodes and a lot of the tubes on the receive section. So my guess is this might have been for a way to externally mute the receive function. I could be completely off base, but whatever. I don't need to use it. I'm probably just going to leave it in there because it's not hurting anything. You can see here it is, right down here, a little added terminal strip. There's, I can stop bumping the camera, there's the transistor, then the 1.1 meg resistor and the diode in parallel are right there. So yeah, kind of a curiosity. I'll just leave it in place. And then the last item to talk about right now, I do need to clean carefully the contacts on the band switch. And just like a lot of rigs from this era, this thing is huge, it's irreplaceable, and it's got a lot of contacts on it. There's 7 switch discs in here, and some of them have decks on both sides. But I do have techniques that I've picked up from watching folks smarter than me online about how to delicately clean those. I don't go brute force in there and just hose them down. I treat them very delicately and just try to get the majority of the oxidation off. So that'll be a project to get these guys cleaned. So that's it. That's the status and my plans for restoring this TR-3 along with the RV3. And I think it's going to turn out to be a great project, and I'm looking forward to getting these back on the air and making some QSOs with this classic rig. As always, I thank you for watching my channel, and especially for sticking with me on what was probably one of the longest episodes I've made yet on Level Up EE Lab. So until next time, bye for now.